Hello, let me first change the view here. Okay, I'll leave it. So, hello, elementary stats class is the first video for our semester. I will put up a schedule so we know what's going on here on out. Okay, as you can see, I have the notes already filled in because it took me several hours to write the notes. So I didn't want to bore you watching me write all the time, but we'll see how it goes. If this is not a good format for you, if it doesn't help you understand, let me know, okay? And before I begin, I hope you're all doing okay. I hope that you're safe, you're healthy, no one you know or around you has the, the virus. So here's we go. So now, first you can see my stat lab homework due Monday 3:30. That's flexible. I'm going to post it today after our vlog. I finish recording this video. I'm going to go through the notes and explain page by page what's going on here, okay? So now we've already done some of the normal distribution. The bell curve, that. Now we have binomial. Bi meaning two possibilities. That's it. Success or not, they call that. Like if I asked, I have a group of 100 people, we already know that 80% of people own a cell phone. If I were to pick 5 people, what are the chances I have 2 have cell phones and 3 don't? Well, the success you would call the cell phone owner, and the not meaning the failures. They're not failure people, but I mean they don't satisfy what we're looking for. Now, the simple case, like coin flip, 50-50, heads or tail if it's a fair coin. Each thing must be independent, meaning with replacement, unless you have, remember, the 5% rule. If your selection is 5 out of 1,000 or all people, you can really say it's independent because one selection doesn't affect really the denominator much. So now, so it's not just coin flips or if you have something or not. It can be like, what are the chances I roll a 1 or a 2. If I roll 6 times, I want to see what are the chances I get 2 times happens I roll a 1 or 2. So the success would be rolling a 1 or 2. The fail would be 3, 4, 5, or 6. Okay? You will see more as we go. All right. I will use a highlighter when I'm talking about something to make sure you see what I mean. Okay? Now, so each event, meaning each time I pick a person, is continually zero point 0.8 or 80% chance I get someone with a cell phone. Okay? It doesn't change. So it's independent. The success and failure thing, that's just what satisfies what I'm looking for and what doesn't. Two possibilities. Like I just said before, we can flip a coin or roll or whatever. You can see the different variables we use show different things. N is how many trials. Like out of 5 rolls, What is the chance I get 3 with 1 or 2? X says how many I'm predicting. I want to know success. My recent example with rolling a 1 or 2, what are the chances I get 3 times it happens 1 or 2 rolling dice? So my successes I'm looking for is 3. P is a probability of the success. Like recent enough cell phone example, if I had, like I say, of all people, we know that 80% of people own a cell phone of some kind. And I'm going to pick 7 people. What are the chances only 2 of them have or own a cell phone? Well, the success probability for each selection is 0.8. And 0.2 would be the failure to not have a cell phone. Okay? Now, that we use Q, some of you will see Q, not always, but you'll see Q meaning the opposite probability. When I say P, what the probability of getting 3 people out of my 7? X equals 3. Now, X is how many successes. P is the probability of success. They're always related. Now here, first example. With replacement, as you know, if we have a big enough group, it doesn't matter. But for now, we'll say with replacement. So I pick one. Now, there's a 0.85% probability they know what Twitter is. Okay? Now, what if we selected 5 random adults with replacement? What are the chances 3 out of 5 know what Twitter is? Okay? So does it satisfy? Is it really a binomial distribution? Yes, because 5 trials, 5 adults. Fixed numbers, not in general. Okay? Dependent, yes. This example, we kept it simple. It's with replacements. We put them back. Now, two categories. You know about Twitter or you don't. 0.85 probability of knowing Twitter. 0.15 probability you don't know what Twitter is. Okay. So now, and the probability is the same. It's consistent, not same equal, but consistent. 0.85 for each success, 0.15 for each failure. Now we figure put the numbers in the right place here. How many trials? How many success? I want to see what the chance is. Probability of success. Probability of failure. So that's all the numbers. We didn't figure it out yet. We will. So hold that. Now, other example, LOL. So asking people, they know what abbreviations we use in text mean. LOL, BFF, whatever. Do you think they're annoying or not? But it says, yes, they're annoying. No, they're not annoying. or I'm not sure. That's one, two, three possibilities. It's not binomial. Now, I already know about this. One second. Get my pen out. So, one second. Okay. All right. Now, remember, if we have a big enough group, if my sample is less than 5% of the group, I don't need to think about fractions, different denominators going down. Okay? Now, that formula. It looks complicated, but it's not really. So, during these lecture notes time, I will add pages that won't be in your already written out notes. So I can add emphasis, okay? I'm going to save time and explain clearly if I can. So now you can see here, n factorial. I will explain factorial if you don't know what it means. And remember is how many did I pick total? Not the group, but I picked 5 adults. N equals 5. How many success? That's x. When I said 3 means x equals 3. P, probability of success. Recent with Twitter, 0.85. Q, the other probability of failure is 0.15. Okay? Now, let me see what I have. The sidebar on factorial. Okay? Okay. Just means 4 factorial, whatever. That 4 times 3 times 2 times 1. That's what's mean factorial. Factorial. You will multiply all the numbers below that number. Okay? And I believe that on most calculators it's there. I have it under probability. If you don't have it on your calculator, you can look online to see where you can find it. Or just do the math. It's not hard. The numbers I'm giving you aren't impossibly big. Okay, so now, a few things. For some strange reason, there's a whole lecture behind this, but I'm not going to do it here. 0 factorial equals 1. Also, reminding you about exponents. If you have any number, raise the zero power, the answer is 1. That will be important going forward. Also, if you will see a lot of fractions with factorial top and bottom. Now, you could do the multiplication. 5 factorial equals 120. 4 factorial, you already know we saw, equals 24. Then you can divide it. Or realize numbers multiply. If they're the same, multiply, you can cancel top and bottom. For example, see what? It's the same. Remember, multiplication, I can cancel. Not 5 plus 4, but you can't cancel that. So that. As you go and get more experience with this factorial arithmetic, you will notice what? Anytime you have the numerator a bigger number than the bottom, for example, same as recently, right? Well, we can write it abbreviated too. Because a factorial is inside 10 factorial. So automatically we can cancel without writing out the whole thing. So practice those things, and you will see we do it again and again in these recent, what we're doing now with binomial probability. Now, back to the notes we already have. 4 factorial equals 24. 3 factorial divided by 3 factorial equals 1. It's the same thing, right? Then 4 factorial, 2 factorial, the 2 and 1 cancel. You can see that. The last one, 2 different numbers in the bottom. 6 factorial, 3 factorial, 2 factorial, right? Well, we know that the 3 is gone within that. And I made a mistake here. Let me fix it now. So I'm hoping you're watching this video because if not, you missed my mistake. Okay. I'll probably post the second version or something after this anyway. So now cancel reduce. And I changed the color last night. I don't like the brown. I prefer the orange. If you can't see orange or it's a problem for you, let me know. Anything I can change going forward, okay? Because I'm doing these more and more often. So now, like I said before, if we had 6 plus 3 plus 2, 3 plus 2, can't do that. Not the same thing as multiplication. Okay? Okay, now, top you can see all their examples is 6 factorial, 5 factorial equals 6. 10, 8, and 3, you can see that. I have in general explanation over here. Okay? Now for some examples. Let me see what page we're on. Okay, not bad. I know this is long. I want to finish it in one time. You can watch it cutting it up. That's fine. Okay, watch it on your time. Now, here we have the Twitter example. N equals 5, X equals 3, P equals 0.85, Q equals 0.15. To find the probability of getting 3 if I chose 5 adults, what are the chances that 3 out of my 5 will know what Twitter means? Okay? Now, like I said before, let exponent work, fraction work. So I went through the answers 0.138. Okay? So this means the chances I get 3 out of 5 who know what Twitter is 0.138. So around 13% chance, 13.8% chance. Now, This is a little more complicated. My answers don't match perfectly what the notes say. And there's a reason for that. So fewer than three. It's not just two. Really, it's if none know about Twitter, one knows out of five, or two knows out of five. Three different probabilities I have to add together. So my first approach, probability of 0 out of 5. Really, that's almost impossible. It seems 0.000759. It's not even, it's 0.007%. Low chance. Probability of 1. 0.00215. Now the probability of 2. Remember, that is how many trial and how many successes I want to know the probability of happening. 5 minus 2, right? So now I have 0.02442. And it makes sense because probability of 3 was 0.138. This should be below that. So now I add up probability of 0, 1 of 2, and that becomes the probability when I add a 0 or 1 or 2. We add that 0.0273 close to 0.026. Let me think, what is that? 0.0266. It's really what, 1 thousandths away, about. So it's okay. Now I did it again, another way. Now this is something we use this to save work. This example didn't save a lot of work. But in the possibility of getting 0 adults, 1 adult, 2 adults, 3 adults, 4 adults, or 5 adults, that's the whole sample space probability. If fewer than 3, 0, 1, and 2, the opposite but similar would be 3 or more, 3, 4, or 5. So I can find fewer than 3 if I take 1 minus the other part. So we try that now. See here, because we're dealing with decimals and rounding, it will cause some error, it's not a perfect answer. So I have 0.0268, really close to 0.0266, or the other 0.0273. Really, you would round to two places probability. So you would say it's really 0.03 for all of it. So it's fine. Now, here, now this is, again, let's not clear exact number. It says getting more than one right. So we have 5 multiple choice questions. So to get the right answer, if it has 5 choices, is 0.2. 1/5, 1/5, 1/5, 1/5, 1/5. 0.2, 0.2, 0.2, 0.2, 0.2. Okay? Now, more than 1 means a probability of 2 or 3 or 4 or 5. That's 4 probability things added up. A better way would say, okay, what about the probability of 1 or less? If I take 1 minus that, it will equal 2 or 3 or 4 or 5. Let me draw something. The total sample space equals 1. I want to know what's the probability I get more than 1 right out of 5. So, so I can take advantage of that. Instead of doing probability of 2, probability of 3, probability of 4, probability of 5, and add together, I can instead say find the probability of 0 right, find the probability of 1 right, add together. Then 1 subtract that will give me the other answer. That parentheses, not critical, but I put it for emphasis. 1 minus this part gives me the other part. Because remember, the whole thing and that's the important thing to think about that, okay? So now, you can see here I decided to do the 1 or 0 and then 1 minus that. So below, probability of 0 right out of 5. Now, probability of 1 right out of 5. Okay? Below that, you can see they're added together, and that 1 minus that. So probability of 1, another mistake I caught. Hold that. I really hope you watch this video because there's another mistake I made. Probability of more than 1 equals 1 minus probability of fewer, 1 or fewer. Okay? Now, good. Almost finished. Now, probability of 0. If we have n equal 8, success is 0.4. Q with a fail probability is 0.6. So now we find what's the probability of getting 0 successes. There is a table for this. If you know the exact probability, and it's not 0.45, it's 0.4, 0.5, 0.6, and how many trials, n equals 8, you can find out each chance of 0, chance of 1, chance of 2, chance of 3. Use a table to calculations too. Okay? So here, probability of at most 3. That means of the add probability of 0, 1, 2, and 3 together. That's here. Now, below now we have exactly 8 is easy, the bottom one. Okay, let's see something here. Good. At least one means one or more. So the whole table, or one minus the one that's not included, probability of 0. Then more than 6 means 7 and 8 added together. Okay? Now, the devil of a problem. I put down the numbers 5.6.4. We did it here. Exactly 3 out of 5. One probability. At least 2 means 2, 3, 4, 5 added together, or 1 minus probability 0, probability of 1. Now we're jumping over the mini tab. You can explore that on your own using my stats lab or mini tab or other probabilities. Okay, possibilities. Now we'll talk about using the mean and standard deviation for this. Now, N and P, N is how many trials. P, probability of success. Q, remember, probability of failure. That the mean plus 2 standard deviation or minus 2 standard deviation means acceptable range within 95% possibility. So inside here, reasonable. Outside is significantly different than what we expect. Okay? Now, see here, those formulas. And over here, the relevant numbers. Below, is the mean and the standard deviation. Now the question was, Is that reasonable? Fine. Is 252 within reasonable or not? Well, no. Because, first of all, if you look at 52 is the mean. It can't be significantly different. But at the same time, we'll look at the range. It's within the range, so we're fine. Now, an exam. True, false on an exam. If you weren't prepared, you didn't know you picked TF, the whole thing, the probability of getting it right is 50-50. Okay? If you had 75 questions, you can expect the average number right should expect about half right, 50%, right? 37.5. And the range of expected answers correct would be 46.1 to 28.9. So the question says at least 45. A little difficult because 45 is within the range. So to expect to get at least 45 really is not reasonable because 45 is the upper limit of what you should expect. 46 where it cuts off. Over 46, it's not reasonable to expect that you get that many right if you're really guessing on each one. Now, M&Ms. Mars Company, who produces M&Ms, he said 24% of M&Ms are blue. Okay, so the mean we say 0.24. If we had 100 M&Ms, average would be 24 M&Ms. Standard deviation would be 4.3. That's the range, expected range. Can get up to 32.4 M&Ms down to 15.4. Really I would say 33 and 15 out because we don't count zero point 0.4 M&M or zero point 0.6 M&Ms. So now the question is, if we have 27 in my bag, I counted 27 blue, is that within? Does that mean 20% is accurate? Yes, because 27 is within the range we have. And now, homework. The paper homework here, 3 pages. Do your best. And ML. I'm going to post it right now after I finish this video. Do your best. Just try what you can and communicate with me what you need, okay? Let me know feedback on this video. I feel like it's too long for sure. And normally I would write at the same time I'm explaining. So we'll see how we go, okay? I hope you're doing well. I think I'm going to have a tutoring time. Well, today I'm working 3 to 5, and I'll see blah. And I will set some office hours this weekend and next week, okay? All right. Good. We'll see you soon. Okay. Bye.